So in today's class we are going to learn about the CNF, that is nothing but the Chomsky normal form. So far we have discussed about CFG, which is context free grammars, and the language which is generated by the CFGs are called as the context free languages. Now today's class we will deal with how to convert a given CFG into a CNF form. So basically when we learnt about the CFG, we learnt that CFG productions are of the form some variable goes to variable union terminal whole star. That means it had variables or it had terminals or it had epsilons, and it could have any number of terminals, any number of variables or a epsilon. So this was the form of the production rules for the CFG. Now we have to convert this CFG into the format which is CNF form. So for this we are going to use three kinds of simplification that we have already studied in the previous classes, that is elimination of the useless symbols, elimination of the epsilon productions, and elimination of the unit productions. So first of all we will see what is a grammar when it is in the CNF form. So we have the definition of the CNF form. Let G be a CFG, then the grammar G is in the CNF form if all the productions are of the form A goes to small a and capital A goes to B, C. So these two are the only two types of productions which are allowed for the CNF form. So the left hand side can be a single variable as it is in the CFG, but on the right hand side we do not have as much flexibility we have in the CFG. It can be only a single symbol, and if it is a single symbol it has to be a terminal symbol, and two symbols are allowed, that is at most two symbols are allowed. If there are two symbols on the RHS of the grammar, both of them have to be variables. So these are the only two forms of productions which are allowed for a CNF form. So our aim is to convert the CFG into a CNF form. So what is the procedure that we follow for this? So the step 1 for the procedure for conversion of the CFG to CFN is elimination of all the epsilon productions. Step 2 is going to be elimination of unit productions. Next, in the step 3, we will eliminate all the useless symbol. So once we have done this, we will convert the CFG to CNF. So the CFG that we get after applying step 1, step 2 and the step 3 is going to be converted into CNF. So what do we do in step 1 of conversion? So the step 1 of conversion is going to take up every production rule which is of the length greater than or equal to 2, and we are going to replace every terminal in those productions by a new variable, and we are going to add the production of the new variable which goes to the terminal symbol that we have substituted. So therefore for every production of the length greater than or equal to 2, and in every production which is in the form of A goes to A1, A2, A3 up to some AN, we are going to replace all the terminal symbols which are nothing but T's with a new variable such that we have X goes to T. If we have some production which is in the form of A goes to BC and A, if we have a production of the form S goes to B small c and small a, then we are going to identify the production which is of the length greater than or equal to 2. In this we are going to see that there is a terminal symbol here. Therefore, we are going to say x goes to small c. We are going to replace this terminal symbol by a new variable, and hence this production is going to change as s goes to b x a, and also since we have replaced c with x, we are going to add the new production that we have introduced, x goes to c. So, this is what we are going to do in step 1 of the conversion. In the step 2 of converting the CFG to CNF form, we are going to consider every production of the length greater than or equal to 3. So, in these productions which are in the form of A goes to A1, A2, A3, A4 up to some AN, we are going to introduce some new variables such that the length does not remain greater than or equal to 3, because the maximum length which is allowed in the CNF form itself is just 2 symbols on the RHS. So, therefore, we are going to convert this into the format of A goes to A1 D1, where D1 is the new variable that we are introducing. Next, D1 goes to A2 D2, D2 goes to A3 D3, and so on up to D of n minus 2 equal to A of n minus 1 AN. So, this is the format in which we are going to convert everything into just 2 symbols being on the right hand side. So, this is what we are going to do. So, therefore, we see here that in case there are n symbols, on the RHS, we introduce n minus 1 new productions and n minus 2 new variables. So, as an example, we will take A goes to B, C, D, E and F. So, this is considered as a to the power of n, this is a to the power of n minus 1. So, this will become A5, this is A4, A3, A2 and A1. Now, this is not allowed in the CNF form. So, we are looking to having only 2 symbols on the RHS. So, we are going to use this generalized formula that we have produced here in order to decompose this. So, therefore, A becomes B D1, D1 goes to C D2, D2 goes to D D3, D3 goes to F E and F. So, therefore, we can see here that from having 5 symbols on the RHS, we have produced something that does not change the meaning, but yet it has got only 2 symbols on the RHS. So, therefore, we will see that n here is equal to 5. So, therefore, n minus 1 productions, that is 1, 2, 3, 4 productions we have produced. So, n minus 1 new productions and n minus 2, that is nothing but 3 variables. So, the 3 variables that we have introduced are D1, D2 and D3. So, this is how we are going to convert the given CFG into the CNF format. We will now look at a problem of conversion of CFG into CNF. So, first of all, we look at the problem, and the first step that we are going to do is eliminating epsilon productions. So, we see that the solution to this is we do not find epsilon productions. So, we can see here that we do not have any production of the form some variable goes to epsilon. So, the second step for this is going to be elimination of all the unit productions. Eliminate unit productions. So we'll find out the unit pairs from this problem. So we have S goes to B. So therefore S comma S is a unit pair. So apart from this, we do not have a direct unit production. Therefore, after the basis step, we move on to the induction step. So we will consider S comma S, and then we have S goes to B. So therefore, S comma B becomes the unit pair. Next, we consider S comma B. We do not have B going to a direct unit production. So therefore, we will stop looking into the other unit pairs. So therefore, we have obtained two unit pairs, S comma S and S comma B. So now we are supposed to replace all the productions with the second part of the unit pair and their non-unit productions. So everything which is in the form of A comma B, generalizing it as A comma B, we are going to replace A goes to B's non-unit production. Non-unit production. Therefore, if we consider S comma S, we are going to replace S with only S's non-unit productions. So S's non-unit productions are A and small a, capital A. Next, we are going to consider S comma B, and we are going to write S goes to B's non-unit production, which are A and AA. So these are the manipulations that we do for the grammar. So next, we are going to write the result of this grammar. So S goes to, we have A and AA. We get those from the two productions that we have written here. Next is A, we will write it as it is as AB, and then B, we again write it as it is, and then we write D goes to A, B, D. Next, the third step we are going to perform is elimination of all the useless symbols which are there in the grammar. So eliminate useless symbols. So for this, we are going to consider first one, which is generating test, and the second one will be reachability test. So we have S goes to A, so S becomes generating, then B goes to A, so therefore B is also generating, and then D goes to ABD, so SBD, all of them are generating. Also we have A goes to AB. So for this B, it is possible for us to substitute A. So therefore this becomes set of all terminals. So all of them, all the variables in the grammar are generating. Next we do the reachability test. So for the reachability test, we consider S, that is nothing but the start symbol, and we know that the productions are A and small a, capital A. The variables which are reachable from this is the capital A. Next we consider capital A, and we consider its production AB. The variable which is reachable is B. So next we consider B and its productions, that is A and small a, capital A. The variable which is reachable is A. So we have already considered A, there is no need to reconsider. So therefore what we notice from here is that D goes to ABD is never reachable from the start symbol, which is S. So therefore we are going to eliminate D and all the production that involves a D in order to find the original, the result of the elimination of useless symbols. So therefore the grammar becomes now S goes to A, AA. A also remains as it is because it is reachable. B also remains as it is because again it is reachable, and nowhere here we have a D. If there was, we would eliminate it, and there is no need to write this D goes to ABD because D is not reachable from the start symbol. So therefore, this is the result of the grammar after we have done all the three kinds of elimination, that is elimination of the epsilon productions, elimination of the unit productions, and elimination of all the useless symbols. And we also noticed here that, and it is very important, the result of the step 1, the grammar that results as a procedure of the step 1, we are going to consider that as the input for the second step, that is elimination of the unit productions. The resultant grammar from the second step is taken as the input for the third step, that is for elimination of the useless symbols. So once we have done this, next step is to convert the given grammar into the CNF form. So we write here CNF form. So for the CNF form, we consider the step 1, where we are going to consider every production of the length which is greater than or equal to 2, and we are going to replace all the terminants by a new variable. So therefore, we consider S goes to A, and then we have A, capital A. So therefore, I am going to convert this into, I will say x goes to small a, x goes to small a. So therefore, this is going to be replaced with a capital X. Here there is a terminal A, but we do not make changes to that production because the length of that production is not greater than or equal to 2. So we are interested only in the length which is greater than or equal to 2. Next we have A goes to AB. So instead of AB, since x goes to A, I am replacing A by x and writing xb. So in place of AB, we write xb. Then we have B goes to, we do not make any changes to this which has got a single symbol, we write it as it is. But here where there are two symbols, we replace the terminal by the new variable x and write A. So as we see, we have all the productions of the grammar in the CNF form. That is, we have either a production which has got only one symbol, and that symbol is a terminal everywhere. So this is a single symbol, and this is single, and this is single. All of them are terminal, and wherever we have two symbols, all of them have to be variables. So x and A are variables, x and B are variables, even x and capital A are variables. So there is no need to go for the step 2, where we consider all the productions of the length greater than or equal to 3, because there are no such productions here. So this grammar is in the CNF form. So now we will look into the next problem. So the problem statement says that S goes to ASB or epsilon, and it has got the variable A and variable B. So the step 1 is to eliminate all the epsilon productions. So we have the production S goes to epsilon. So therefore we find that S is a nullable variable. So since S is a nullable variable, we will find out if there are more variables which are nullable. So there is no production which directly says it is yes. So this is the only nullable variable. So next we are going to substitute epsilon for S everywhere in the rest of the productions and write all the possible productions. So the grammar is going to become ASB or epsilon. Next we substitute epsilon for S, and therefore we get the production AB. Next we have A goes to A, capital A, S and A. Now in case if you substitute epsilon for S, there the production is going to become AA. Next we have B. B goes to S, B, S, A and BB. So in case if I substitute epsilon for the first S, we are going to get the result as BS. In case if we substitute epsilon for the last S, we are going to get SB. Now in case if we substitute both the S's for epsilon, we are going to get the production for B. So therefore, these are the different productions which are resultant from the elimination of all the epsilon productions. Next, from here we are going to eliminate all the unit productions. So therefore, step 2, we see that there are no unit productions in this. We go to the step 2. So the step 2 says that we have to eliminate all the unit productions. So in order to eliminate the unit productions, we will find out if there are any unit productions. So we have B goes to capital A. So we write here B goes to capital A is a unit production. So there are no more unit productions apart from this. So therefore, B comma B is the unit pair that we obtain from the basis step of elimination of unit production. So the second step, which is the induction step of the elimination, states that we are going to consider B comma B. We have the production B goes to A, therefore B comma A is also a unit pair. Next we are going to consider B comma A, and we will see that A does not have a direct unit production anywhere, so we don't have anything. So therefore B comma B and B comma A are the two unit pairs. Next we are going to make the substitution. So first we will consider B comma B, and we will write B goes to B's non-unit production. So B has got several non-unit productions and we are going to list out everything. So it is SBS, the first one, next BB, then we have BS, next we have SB and B. So we have SB and B. Next we have the unit pair B goes to A. So we are going to make the substitution B goes to A's non-unit production. So we will write all the productions of A because all of them are non-unit productions. So therefore B goes to A, capital A, S, and then we have A, and then we have A. So therefore we will write the final grammar here. So in the final grammar we write S as it is. So we have not made any changes to productions of S, therefore we write it as it is. Next we take A. We have not made any changes to A's production anywhere, so therefore we will write this as it is, AAS, A and AA. Next we have made changes to the productions of B. So therefore these two, B goes to the first line and B goes to the second line, all of them together are going to become the productions of B. So we will write them one after the other. So it is SBS, BB, BS, SB, B, A, capital AS, A and A small. So this is the final grammar we get after we have eliminated all the unit productions. Next step is step 3, and it is elimination of all the useless symbols. Eliminate useless symbols. So we will look into two kinds of tests here. So one is the generating test and the second one is the reachability test. So the generating test says that, so we will consider the grammar which we have got after the elimination of the unit productions. So we have A goes to small a, which is generating, and then we have B goes to small a, which is also generating. And next we will see S goes to AB is present. So therefore A can be substituted for small a, B can be substituted for small a. So therefore S also is generating. Next we do the reachability. So for reachability, we will consider the start symbol and its production. So S goes to ASB epsilon AB. So therefore the variables which are reachable are A and B. So both the variables which are there in the grammar, that is A and B, are both reachable by S. So therefore we do not make any changes to the grammar, and the resultant grammar is going to be the same because we have not eliminated any symbols after the previous result. So now we are going to consider this grammar in order to bring it into the CNF form. CNF form. So now in the step 1, we are going to concentrate on every production which is of the length greater than or equal to 2. And we are going to replace all the terminals in those productions by new variables. So we are going to take S goes to ASB. So it does not have any, this is ASB, it does not have any terminal, so we will keep it as it is. And here I think I have missed and written the epsilon production, which will not remain in the grammar. So that production has to be removed. So therefore next we have AB. So we do not make any changes to this because there are no terminals. Next we have A goes to. So we see here it is of the length greater than or equal to 2, and there is a combination of terminals and variables. So here we make the replacement, and the replacement that we are going to do is X goes to A, that is the new X variable that we are introducing. So therefore this is replaced by X A S. Next A we keep it as it is because we are not touching anything, we are not making changes to the length 1. Next we have small a capital A, so that is going to become X capital A. Next we consider all the productions of the B. So B has got SBS. So therefore we need one more variable, that is nothing but Y goes to B. So we have Y goes to B, and now we will make the changes to the productions of B. So SBS is going to become SYS. Next we have BB. So BB is going to become YY. Next we have BS. So this is going to become YS. Next SB. So this is going to become SY. Next we have a small b, and it is a single symbol. So B will keep it as it is. Next we have A, capital A and capital S. So this is going to become XAS because we have X goes to A. So in place of A here we have put X. Next we have small a, length 1 we will keep it as it is. At last we have XA. So here it is A. So in place of A, so here I write the last production, which is A capital A. So this A capital A will become X capital A. So next we are going to consider everything which is of the length greater than or equal to 3. So we will just put a circle to all those productions here. So these are the productions that require some changes because 3 symbols are not allowed on the RHS. So we know the step 2, which is the decomposition, and we have considered the length greater than or equal to 3, where we are going to consider the length greater than or equal to 3. So these are the productions which have got the length greater than or equal to 3. So the first one is S goes to ASB. So we are going to change this into S goes to A D1, D1 goes to SB. So we have made the decomposition. Next we are going to consider A goes to XAS. and we are going to make the changes as a goes to x d2. So since I have used d1 here, I am not going to repeat the same variable. I am going to take a separate variable, that is d2. Next is d2 goes to as. d2 goes to the last two symbol. This is an, this is a of n minus 1. Next, we will consider the third production, that is nothing but b goes to sys. For this, we will make the production once again. So b goes to s d3, again a new variable d3. Next, d3 goes to ys. So we see here that the productions which had got 3 symbols are reduced to 2 symbols on the RHS, and we have introduced new productions. And next we are going to consider b goes to xas. Now since we already have xas and we have already done some substitutions for xas, there is no need to introduce a new variable d4. So what we are going to do here is b goes to x d2. It is going to remain the same because xas, so it is going to become x d2, the same variable, and then d2 goes to as. So this is going to remain the same. So since the RHS are equal, there is no need to introduce a new variable. So now we are ready to write the final grammar. So therefore, the final grammar can be written as S goes to, we will take up all the productions. S goes to, we will write all the productions that we have written here. S goes to A D1, we will write it as it is, and this AB has to be written as it is. AB has to be written as it is. And then there is one more production that we have written here, D1 goes to SB. So here D1 goes to SB has to be written. Okay. Next we have A goes to, instead of this XAS we have produced XD2. So we write here XD2, and A and XA are going to remain as it is. So A is going to remain as it is and XA is going to remain as it is. So we have introduced D2 here. So we will also write here D2 goes to AS. So this D2 goes to AS. Next we have B goes to, so B goes to SYS. In this SYS, so B goes to SD3 is there. So write SD3 and D3 is introduced. So we'll add D3 goes to YS. So SD3, and next YY will remain as it is. So YY is going to remain as it is. Next YS is going to remain as it is. SY is going to remain as it is. B is going to remain as it is. Next we have XAS. Instead of XAS we have XD2. So we are going to write XD2 instead of this. Okay. And D2 goes to AS. It is already present, so there is no need to write it once again. Next, after this we have A, and then we have X capital A. Also we have X goes to small a and Y goes to small b that we had already introduced. So we are going to write them as it is. So therefore, this is the final grammar that we get after converting the CNF, rather after converting the CFG to CNF. So if you observe the grammar here, we have S goes to just the 2 symbols everywhere, and wherever there are 2 symbols everywhere they are variables, and wherever there are single symbols all of them are terminals. So this is the procedure for converting a CFG to CNF format. Thank you.